We'll beginning with the file system interface chapter. So in this chapter we're going to learn about what is your file system, so how file system is going to be organized. Okay, so what are the different directory structures, okay, how we are going to mount the file system. Okay, so first we'll be studying about, okay, what are the objectives, what are the concepts of a file system, so what are the access methods, so disk and directory structures, and file mounting, file sharing, and file protection. Okay, so the main objective is, okay, to explain the functions of file system, to describe the interfaces of the file system, so how do we how the files are getting accessed by the users, so what are the different types of interface we're going to have. Next, to discuss the file system design trade-offs, including the access methods, file sharing, file locking, and directory structure. Okay, to explore file system protection. Okay, next, okay, we are going to study about what is a file. Okay, so file is nothing but a list of contents of your text, okay, or it may be your binary information, or whatever it is. Okay, so all information about a file will be contiguously stored, okay, in a same address space. Okay, so in the previous chapters we have learned about the paging and segmentation, so where we are going to store our programs or files, okay, in the scattered memory location. So that means all instructions are not appearing one after the other. Okay, so you may have a block of information stored in one location, another block in another location. Okay, but in this case, so the file means all the information will be available in the contiguous memory location, so one after the other. So sequentially your instructions will be stored. Okay, there are different types of files. You may have a data as a file, you may have a program, also can be referred to as a file. Okay, so it is not only that data what we are going to have, but also the program as files. Okay, so you have in data file you may have a numeric data stored, you may have a character data, or you may be storing only the binary information, that is ones and zeros. Okay, so contents of your file will be divided by the person who is creating a file, who is called as a file creator. Okay, so there may be many files, you can call them as a text file, you can call them as a source file, that's the programs what we're going to write, and executable file, so with the extension .exe, so which is in the form of a executable operation. Okay, if we just run that particular file, so it is executed. Okay, so there are different file attributes, so like, okay, every entity is having its own properties, so like that your files are also having a different properties. So file will have a name, okay, so through which the humans are identifying the particular file. Okay, so your operating system is going to give the identifier or a unique tag, so which identifies the files within the file system. Okay, and the type of file. Okay, so for what purpose we are going to use that particular file. Okay, and the location, so pointer to the file location, so it is the pointer which is telling that where exactly your file is. Okay, and size defines what is the size of your file. So protection defines what are the mechanism of protection you're going to attach with that particular file. So whether the file is readable, writable, execution. Okay, so whether the file can be accessed by all. So there are different mechanisms. Okay, and other file is having the attributes like at what time it was created, which date it was created, okay, and user identification, who has created that particular file. So information about files are kept in the directory structure, which is maintained on the disk. Okay, so there are many variations, including the extended file attributes such as a file checksum. Okay, so this is information about a file. So next we are going to have the file operation. So file is an abstract data type. Okay, so we are abstracting the entire contents of a file, okay, with one particular name. So you are calling that as a particular file. Okay, so operations what we perform on a file is creation of file. Okay, so writing into a file, okay, reading a file. Okay, so reposition with a file, so you can use a seek operation. Okay, so anywhere at any point you can seek to that. Okay, so you can locate to that location, and then you perform a read or write operation. So that is actually called as a read operation. So you can delete a file. Okay, so you can truncate a file, so you can split the files, okay, or you can join the files, you can open the files, and you can close the files. So whenever you open a file pointer will be returned. Okay, so which will be giving the information about the location of file on the disk. So likewise, so whenever a file has to be closed, so it will be closed by using the same pointer. So open file, so operating system always maintains several pieces of data. Okay, so you have open file table, so which keep tracks of all the files which are open. Okay, so it will have a file pointer, so pointer to the last read and write operation into a specific file, so or per process, so that has a file open. Suppose if you are having 2 to 3 process 1, process 2 and process 3, so it will keep a file pointer for process 1, okay, different file pointers for process 2, different file pointers for process 3, okay, and keeps track, okay, which location of your file is being read or written to by a particular process. So that entire information will be there in the open file table, which will have a list of the files open. Okay, and file open count will give the count of number of times a file is open, okay, to allow the removal of data from open file table when last process closes it. So that means that, so whenever you open a file and whenever you close a file, lots of operations would have been done. Okay, so in that there are several intermediate data have to be is created. Okay, so like temporary data is created. Okay, so whenever the file is closed, okay, so all the data has to be removed. Okay, so for that it will keep track of how many times the file was open and how many times it was closed. Okay, so after that it will erase all the contents related to that. Okay, so this location of file, so cache of data access information, so that means it is whatever the frequently accessed information of the file is there, it will be stored into one particular location, and every file will have access rights per process, okay, access mode information. So that means for a particular process, so whether that process is only allowed to read, or whether the process is allowed both for reading and writing or modifying it, okay, whether the process is having a rights to access. So you must have seen in the C programming, okay, so we will always open a file using a read mode or a write mode or in such particular fashion. Okay, so you can also have a log, okay, implementation of a log for protection of your files. Okay, so this is provided by some operating system, okay, and the file system. So this is similar to a readers or writer log. Okay, so if reader means only the file is readable, so writer means, okay, so whoever is having that particular log, so they can write into that particular file. So before writing into your file, they have to acquire a writer's log. Okay, so shared log, so this is similar to a reader log, so several processes can acquire concurrently. So same log can be there with a multiple process. So likewise you have an exclusive log, okay, similar to your writer log, so only one process can acquire this log. So after that particular process finishes it, it can release that particular log. Okay, so now you can have mandatory or advisory access, okay, on a file, so depending on the logs it is holding and requesting. Okay, so advisory process can find status of log and decide what to be done. Okay, now mandatory means here advisory at the time of a request, so your decisions can be taken. Okay, so depending on the status of a log. Okay, so here in mandatory means access is denied depending on logs held and requested. Suppose if it is an exclusive log, okay, so any other process is requesting for that log, okay, so the access is always denied, okay, because writing has to be done by only one process. Okay, so there is an example in Java APIs. Okay, so like that you have another example. Okay, so now here there are different types of files what we have. Okay, so executable file, so we will have extension exe, okay, so ready to be run machine, okay, which is in the form of a machine language. Okay, so object file, so usually with the extension of object, so this is a file which is in the compiled format. So machine language, it is not I mean it may be in machine language, okay, but it is not linked, okay, not linked in a sense to all the other modules and all that. So you are just compile your program. Okay, so source code, okay, so any program you write in C, C++, okay, so Java, okay, so assembler, parsem, okay, so assembler, so source codes in various languages. So in similarly batch file, so if a group of commands we can term into your batch. Okay, so and you run all the commands in the terms of batch, that is called as a batch file or shell files. And text files, okay, you have word processor files, you have a library files, so library of routines for programmers. So next print or view, so ASCII or binary file in a format for printing or viewing. Okay, so related files grouped into one file, sometimes compressed for archiving or storage. Okay, so like that you also have a multimedia file, so binary file containing audio or AV information. Okay, now file structure. Okay, so sequence of words, so it is nothing but sequence of words or bytes. So simple record structure, so you have a lines or fixed length. So now you have you may have a certain lines, or you may the lines may be a fixed length or a variable length. Okay, so complex structure, you have certain formatted document. Okay, so and those formatted documents, in essence, like after some keywords, after some fields, you can have a delimiter. Okay, so the delimiter can be exclamatory mark, okay, or a colon, okay, so or a full stop. Okay, so you decide the certain formats for your files. Okay, so that it is easy for you to retrieve data, any amount of your data from your file. So this, in the advanced type of file now, we will have a formatted structure. Okay, so and any location you can load that particular file. Okay, so now it can simulate last two with the first by inserting appropriate control characters. So these two can be done by using the same simple structure but introducing the extra control characters. So the operating system will actually decide what is a format to be there, and the program which is using that so may also decide how the format of a file should be there. So you have a sequential files like this. Okay, see all the sequential file, as I said, file is contiguous data. Okay, so continuously you're storing a file. So you have a beginning of a file, you have an end of a file. Okay, so you are having a current position of file. So from where, okay, your pointer showing. So from where the currently the data has been read. Okay, now if you want, you can proceed by read next or write next. Okay, so if you are writing in a file, or if it is already the file is written, by using a read next command you can proceed here. Okay, so if you want to go to the beginning, you can also go rewind the particular file. So access methods, you have a sequential access. Okay, so we use a command called read next and write next. Okay, or reset, which is again going to the file pointers repositioning at the beginning. Okay, so you can also set it to the end. Okay, or you can also have a direct access. So file is a fixed length, you know that it is a fixed length of logical record. So read end and write end, directly you read the nth block or write into your nth block by positioning to the required format. Okay, so relative block numbers allow operating system to decide where file should be placed. Okay, so sequential access, okay, you have a command called as reset, where current pointer will be repositioned to the 0. So read next, so read is current pointer, so CP will be again incremented by 1. So write next, again current pointer will be there, current pointer will be incremented by 1. So this is sequential access on a or a direct access file. Okay, so other access can be, okay, you can have built on the top of your normal standard methods. Okay, so you can also create an index file. So keep this index in memory. Okay, first determination of a location of data to be operated on the particular file. So it means that if you are having your length of your file is very large, okay, so when you want to search your particular file using your sequential method, okay, or a random method, is not that fast to search. Okay, so in order to make your search faster, so we are creating another index file, so where we are storing the index. So searching an index is faster than actually searching into your file. So in the index you actually get the location of a respective record. Okay, so that is a advanced method, another method of accessing a file. So that is using a index method. Okay, if it is too large, index in okay, so index of the index on the disk can also be created, like how we are creating pages of a page. Similarly, index on an index can also be created. Okay, so like example you can see here. So this is a file. Okay, so there may be lots of, you may be having 50,000 records here. Okay, so there may be lots of information there. Okay, so lots of records are there. So to search all the records, okay, so it is difficult. Suppose if it is sequential access, then searching, if you want to access the 40,000th record, then you have to start searching from the first to 40,000. Okay, so instead of that, so you create a index file. Okay, so now here, okay, so you index, you can take last name as a primary key. Okay, so you are having a fifth Smith here, this is the last name, so that you are storing as a primary key here. Okay, and in this location you are actually keeping the logical record number. Okay, so logical record number you're keeping it here. So if you want to access, so searching index file is easier. Okay, so if you are having this kind of a structure, you can use a hashing techniques and all to actually get the respective number at the faster rate. So then this logical number can be used, okay, record number can be used to search this particular fetch this particular record. So now you're having we'll see what is a directory structure. So directory is nothing but a collection of nodes, so which is having the containing information about all the files. Okay, so you can see here, so these are the nodes which are representing your directories here. Okay, so one particular directory may have any number of files, so both the directory structure and the files will be residing on your disk. Okay, so disk structure is like how this disk will be organized. So disk can be divided into your partitions. Okay, so each disk can be protected by using a RAID method, so which we'll be seeing in the future models. Okay, so this is one of a protection mechanism. So disk can or partition can be used raw without a file system. So without any establishing any file system, we can use a disk, or we can format that with a particular file system. Okay, so partitions of your disk, you can call that as a mini disk or your slices. So entity containing file system is known as a volume. Okay, so in the disk, okay, you're storing your programs or data and all. So the portion where you are storing the file system, so is called as a volume. So file system will give you the information about the files and directories available in your disk, okay, along with the locations where exactly your information is stored. So that is what a file system. So file system is actually helping us to retrieve the information at the faster rate in an easy manner. So that is why we require a file system. So the portion where we store the file system is known as a volume. Okay, each volume containing file system, okay, also tracks that file system information and device directory or volume table of your content. So your operating system also maintains the volume table of content. So that means like how it is maintaining the open file table and all that. Okay, so like that it keeps a separate table which is storing the information about the file system. So that is called as a volume table of your contents. Okay, so as well as general purpose file system. So there are many special purpose file system, so frequently all within the same operating system or computer. Okay, so general file system is normally what we store and retrieve data for. Special purpose file system, if you are on a network and or if you want to share your files, so you require a special purpose file system. Okay, so here you can see that. Okay, so we have partition A, partition B and partition C. So you have a directory here. Okay, so you have a files, so you have a directory file. So this entire thing is one disk. This disk can be sliced, we can create a two slices here. Okay, so you have partition A and partition B. Okay, so likewise you can combine two disks, or the entire disk can be logically acting like a one particular portion or one particular slice. Okay, so you may have different types of your file system. So these names are different depending on what type of operating system you are going to use. So you may have some general and some special purpose file system. So Solaris has like the temp-fs. Okay, so memory based, okay, which is volatile fs for fast temporary IO. So it is having object fs, so interface into a Cont. Okay, so like that for different things it is having a different file system. So the names depends on what type of operating system you are going to use. So the operations what we perform on a directory is search for a file, so create a file, so delete a file, okay, so list a directory, okay, and then rename a file, so traverse the file system. Okay, so you can search into a particular file, so file in a directory, you can create a file, so in a directory, you can delete a file in your directory, so list all the files in your directory, and you can rename a file in your directory, or you can traverse your file system to search out what are the different files available in your directory structure. Okay, so logically what we do, we organize, okay, the directory for the purpose of efficiency, so that it makes us easy for us to recognize a file quickly. Okay, and we give a naming, convenient naming for that, so that easily we can relevant to the topic what has been stored into your disk, so we are giving a names according to that. Okay, I am creating a directory like with a name operating system, okay, and all the operating system related material I am storing in that particular directory. Okay, so that I give this name, so that it will help me that to quickly access the subject content. So like I like that I can have another subject like C programming, okay, so where all the C related content files will be storing in that. Okay, so like that I can have a BDA folder or a directory, so in that all the BDA related files will be storing into that. Okay, so that it is easy for us to help that. Okay, so and we and sometimes we want to group a particular kind of your file, so logical grouping of files can be done, all Java programs into one, all games into one, so like that we are going to have it. Okay. So now we are going to have different types of your directories. Okay, so the small easiest one to implement is a single level directory, so where all the directories are coming at one particular level, so it is very easy to implement. Okay, but then we are facing with a naming problem, like all the files here need to have a unique name. You cannot keep, okay, so more same name for more than one particular file, and you cannot even group it. Okay, so grouping helps us to access of a data easily, but it is easy for us to create the file. Okay, so next is a two-level directory. Okay, so two-level directory, so which is easier, so where each user gets a different user space. Okay, so now user 1 so is getting a different space, user 2 is getting a different space, so user 3 can have its different space, like that user 4 can have a different space. Okay, so for system this thing files and all, you can create a another directory for that. Okay, so like that for system folders is a thing, another directory may be created, so each user is having a own space. Okay, so for that you need to have a path name defined. Okay, so that you are calling it as a search path. So to search the list of directories, okay, to be searched, a list of subdirectories to be searched. Okay, or if you want to execute particular file. Okay, now if you are giving it, so you can also set the path. Okay, so where any supported files for that will be available, okay, to execute that. So the path also can be searched. Okay, so whenever you want to execute your file, if you are giving that command in the current directory, so you need to set the path. So for that program to run, the supported files may also be needed, so you can give the list of all the path, okay, the complete path, so where the files could be found. Okay, so that it is helping that to execute that particular file there. Okay, so now you can have the same file name for different users. Okay, so now you can see that user 1 is having one file with name A. Okay, like that user 2 is also having a one file with name A. Okay, so similarly user 3 is also having, user 4 is also having a name A. Okay, so he is having one file with name data, so that user 2 is also having one file with name data. Okay, now user 1 is having one file with name test, user 3 is having one file with name test. Okay, so now you can have same name, same file name for different users. Okay, so that was not available in the previous single level directory. Okay, and efficient searching is possible, but the grouping capability is not allowed here. You cannot group, okay, make the groups of the files. Okay, now tree structure directory, so here it is advantage over the two-level directory here. Okay, so where you are providing along with having the advantage of having different user space. Okay, you can also have same name for different users. Okay, but the grouping capability is provided in the tree structured directory here. Okay, so you have a absolute path or a relative path you're working out here. So absolute path means you need to give the complete path. Okay, suppose if you want to access this all, okay, Okay, you have to start from root, okay, and then come to mail, okay, and then you are coming to your copy, and then you are coming here. So complete path has to be given. Okay, so you can both work out with absolute path or relative path. Okay, so relative path means if you are accessing this particular file in this directory, okay, if you are in current directory, you need not specify the complete path here. Okay, you can directly run that particular file, commands related to this particular file. So that is with the current directory, if you are already in the current directory. Okay, if you are in the other directory and you want to access the commands or run the commands on this, you need to give the complete for this. Okay, so now if you want to delete any particular file here, okay, so all the files into that subdirectory has to be deleted first. So that has to be done here. Okay, so directories are also stored in the same way how the files have been stored. So you have directories created, under that you can have multiple directories created. So how the naming convention, whatever you are following for files, okay, how the storage structures, whatever you are following for files, same thing is also applied to your directories also. Okay, so it has advantage that naming problem is not there, even grouping problem is also not there. It is working out both with your absolute path as well as a relative path. So you can create a directory, you can delete a directory. Okay, so efficient searching is possible here. Okay, so you can have grouping capability, you can start working with the current directory. Okay, so you like if you are creating a new file is done in the current directory. Okay, so you can delete a file by using a remove command. Okay, so you can create a new subdirectory in the current directory by using a make directory command. So if you want to delete mail, deleting the entire subtree, you have to first delete this thing, then after that you have to delete this one. Okay, now okay, advantage you have if you want to access the same file, okay, so from more than one directory, so that was not possible in case of your tree directory. Okay, so one particular file cannot be shared by more than two directories. So only one file is there in one particular directory, so only in that directory you are going to work. So you are not providing the shared access to multiple directories in case of your tree structure, but in this, okay, so one file can be shared between the two directories. Okay, have shared subdirectories and files, so even the directories can also be shared. So this directory is shared by these two. Okay, so this is advantage in your Acyclic-Graph directory. Okay, so same file, okay, if it is needed to be accessed by more than one, you can do it. Okay, so now here you have two different naming, okay, aliasing. So one you can have one particular name, and you can also have a alias name using which you can access. So alias name is you can have a shortcut names to which you can access it. So this is advantage of having the alias name here. Okay, so here because you are having two pointers, so you are getting access from like your two different things. Okay, so one directory is deleted, if dictionary is deleted, so you will have a list of your dangling pointer. Okay, so like here you can see. Okay, so this has been if it is you are accessing using a alias name. Okay, so from here as well as here, or from here as well as here. Okay, so one thing is deleted. Okay, so still the pointer is pointing to here, so that creates a dangling pointer. Okay, so two pointers are actually pointing. You are created a pointer 1 and pointer 2, so both are pointing to the same file. Okay, so if you have deleted that particular file, okay, then the pointers are still pointing to the same location, so that is called as a dangling pointer. When file is no more existing, okay, but the still pointer is also have to be removed. Okay, if it is not removed, it is called as a dangling pointer. Okay, the solutions for that, you can use a back pointer scheme, so that you delete all the pointers. Okay, so that no more you are going to have a back pointers. Okay, so back pointers you apply using a daisy chain organization. Okay, so where entry hold count, I mean how many pointers were created, to which files it is been pointing, all those information you can have hold count solution. So using this you can solve that dangling pointer. See, dangling pointer is nothing but like here one particular pointer is pointing to one file, another pointer is pointing to that file. If file is closed or deleted, and the pointers is pointing to a location where file is not existing. So this is called as a dangling pointer. For that you can resolve that using a back pointer scheme. Okay, So now here you have two types of link. So one is called as a hard link. New directory or entry type can be recognized using a link. Okay, so you have a hard link and a soft link. Okay, so hard link will have multiple as you are having multiple directory pointing to a particular file, or you can have a subdirectory straight between multiple directories. Okay, so hard link will give you the path, okay, of a multiple directory, the location of that, so where the common shared file will be accessed. So multiple directory will be pointing to the one particular file or a subdirectory. So that is called as a hard link. Okay, so it will give you the reference count, okay, or you can call it as a link count. Okay, how many files, okay, how many directories, how many multiple directories are accessing that particular file. So that is there in the hard link. Okay, so this is for ordinary files in the or the same file. So you also have another option called as a symbolic link here, so which gives information. Like symbolic links are nothing but like shortcuts. Okay, so you have seen in the on the desktop we create so many shortcuts. Okay, so that is there in the Microsoft. Okay, so using shortcuts, so that will give the information where exactly the files are available. So we always create a shortcut that is nothing but a symbolic link. Okay, so which is on the desktop. If you click that, you actually get the contents of that particular file, so which will have a information. Okay, so where to find the link for both the directories or the files there. Okay, so this is the advantage in the acyclic directory, where we can have multiple directories accessing to the one particular file or subdirectories. Next we will have a general graph directory. So general graph directories, okay, so symbolic links, okay, you can have allow symbolic link to directories but not to your files. So because you have like if you are having a cycle this thing, okay, so in searching the thing you'll it will create a lot of problem. Okay, so for that what we do is, so allow links only to files, not the subdirectories. Okay, so you are allowing the links to files, not the subdirectories. Okay, so whenever you are performing any search, run the search algorithm, you are checking that with there are no cycles, because cycles will always create a lot of problems. Okay, so when you run the search here, okay, so actually subtrees will be disconnected, okay, in the search algorithm, so that you efficiently search for one particular directory or your file. So though the subtrees are disconnected, okay, but reference count is not reduced during the search. Okay, so here you always run for do the garbage collection using the check disk command and all that. Okay, okay, so we always ensure that allow links to files, not the subdirectories. You always keep on running the garbage collection. So every time a new link is added, so you check that a cycle detection algorithm to determine whether it is creating any cycle or not. So you always try to avoid a cycle. So next topic we'll be studying about the file system mounting. Okay, so file system must be mounted before it will be used. Okay, so earlier days, okay, so whenever we used to put a floppy in your disk, so before using that file, floppy contents of the file, okay, so the file system had to be mounted. So like that earlier, nowadays if you're just plugging in and plugging out using a USB. Okay, so earlier days if you are putting a pen drive into your system, so first you need to mount that into your file system, which location it will be mounted. After that you're going to access it, so that is called as a file system mounting. Okay, so it has to be, file system has to be mounted before it can be accessed, and after that you have to unmount a file system. So this thing are at a particular mount point. Okay, so you can see here. Okay, so an unmounted file system is a mounted at a mount point here. Okay, so somewhere here you're going to have. So you can mount at one particular mount, or you can mount, you can remove at one particular point. Suppose if you want to add this, you can add it here. Okay, so from there the root this information can be added. After that you can remove a particular branch from this particular thing. Okay, so like you had so here you're having users. Okay, So the users is attached with a bill. Okay, so user is attached with a bill here. So now this thing can be mounted at this particular place when this has been removed, or anywhere you can add depending on the current access. Okay, and here see here, so users, okay, that particular SU is actually mounted at this particular position. Okay, so that is giving exact point where you want to access. Okay, next is file sharing. So sharing of files on multiple users is always desirable. People want to share the files, but whenever it is shared, it needs to ensure a protection mechanism. Okay, on distributed systems, files may be shared across a network, so there they'll be using a NFS file system, which is commonly used in a distributed system. Okay, if multi-user system is there, so always you have a user ID to identify the user. So according to that ID, you can allow the permissions set or remote for that. Again, you have a group ID, allow users to be in groups. Okay, so you own and decide whether the owner of a file has to be given the access, or a group or file has to be given the access, and so on. So file sharing, okay, you can have users networking to allow file system access between the systems. So you can do manually by using the FTP protocol. Okay, it is automatically done in the distributed file system and semi-automatically done in the worldwide system. Okay, so client server model allows the clients to mount a remote file system from server. Okay, so it will allow you the clients to mount the remote file system from servers, so that they can upload and download the files from the servers. The clients are always uploading and downloading the files from the servers. Okay, so for that it will allow the it will give you support for doing the mounting. Okay, so client and users identification is insecure or complicated, so for that you always need to have the protection mechanism. Only the protected clients have the protection has to be ensured for files whatever they upload or downloaded. Okay, so like for that we are always having a NFS and CFS mode. Now distributed information system, so distributed naming services, you can use it. Okay, now file sharing. Okay, all file systems have a failure mode. So if your files are corrupted, so directories are corrupted, that corruption, that is nothing but a corruption of your metadata. Okay, so you can also have a remote file system failures. Okay, so due to network failure, server failure. Okay, so recover from failure can involve status information. If you know the status of failure and all that, the information before that, you can actually recover from the file system failure. Okay, so you have a status protocol such as NFS v3, so which includes all the information in each request, how the request was made, how it was sanctioned, all that. So using this you can actually recover from the failure. Okay, now consistency semantics, so specify how multiple users are to access the shared files simultaneously. Okay, so like that this will be used in a different file system and all, how they are going to be accessing the file system. Okay, next is the protection. Okay, so protection, file owner or creator should be able to control what can be done on the files for the created and by who. Okay, so that means the owner is deciding what access methods is allowed on that particular file what he has created, and to whom is going to allow. So types of access is read, write, execute, append, delete, and list. So the owner will decide who can read, who can write, who can execute, okay, who is having the authority to append. So whatever he is giving, according to that only the access can be done to that particular file. Okay, so you have an access list and group. So mode of access, you have a read access, you have a write access, and you are having a execute access. So three class of users on Unix or Linux you have a owner access 7, so you have having 111. Okay, group access is 6. Okay, so that means here all the rights are given to the user. So group access, so that means read and write access is given for the groups, but not the executes. X stands for execute. Okay, like public access 1 means, so all are given the access of execution, but they cannot read or write the source code. Okay, so sometimes you have certain applications where you're just using them, okay, but you don't know how those applications are built up. Okay, so you don't know the source code of that, and you cannot modify the source code for that. Okay, so that is a public access. So this values are determined by, like, you can, if you're having 8421 code, so 421 code is going to define this. 4 plus 2 is 6, 6 plus 1 7. So this 421 code is telling the number. Okay, now if a manager is creating a particular file, say G, and add some user to the group, okay, now by setting this number, you are using a change mode command to set the number, okay, 761. Okay, so 761. So if he is giving change, see, he has created a file called game. Okay, so if I am giving change mode 761 on this particular file game, so this means for public, okay, the access right will be this one. Okay, so for group it is 6, means this will be this permission. For owner, this is 7, means all the permissions are set. Okay, so if I want to give all the rights for all of them, then the value of change mode will be 777. Okay, so now attach a group to a file. Okay, now I am attaching this particular group, okay, to this particular file by change group G game. Okay, so that, like that, we are attaching into a particular group. So whatever access rights you want, so these numbers have to be modified, and then this format you're going to write it. Okay, so this is an example in Windows 7. Okay, so these are the examples, okay, what we see in UNIX. Okay, so for this is a information set. So first 3 is for public, okay, so owner and group and owner. Okay, so this, seeing this, so D here stands for your directory. Okay, so here it means that, okay, so only read permission is given for public. Okay, so for group, read and write, no execute permission. So here only read and write. Okay, so this here it's indicating this, it is a file. So this D stands, it is indicating it is a directory. Okay, so now here, okay, the owner is having read, write and execute, and all the other permissions are restricted. Okay, restricted for the others. Okay, so it is only a private document. Okay, so like that, here you can see that execute permissions given, no write permissions given, read permissions given. Okay, and all these permissions are given for all. Okay, so by saying this, you can decide what other permissions are set, and this way you're going to ensure the protection, add on the protections onto the users. Okay, so this ends your chapter. Okay, so next chapter will be about a file system implementation.